as I was saying at the end of the other video, this equation will show up again and again and again in this course. Okay, so box it. It is one that we will use over and over again. The others, we've used them we'll use them to derive or explain, but this one we'll actually use for calculation. So make sure you box it. So it's called voltage or electric potential difference or potential. Okay, and it's measured in volts. All right. With one more equation, and then we're ready to go to electricity. The one other equation I think you probably already used, and it's a common sense one. It's the number of elementary charges should be equal to the total charge an object has divided by the charge of one elementary charge. So if you were looking for the number of electrons, you would take the total charge and divide it by the charge of one electron. Kind of like if you were looking for the number of $5 bills on the table and you knew there was $200, you would divide the 200 by $5 and get the number of bills. So if you know the total charge, then you will divide by the charge of 1 and get the number of electrons. Okay? So that is then everything you need to know in electrostatics so that we can move to magnetism. We do need to do a little bit on electricity though as well, okay? And some of this you will remember, I think, from grade, what was it, 10? Okay? So when we talk about electricity, the difference between electricity and electrostatics is now instead of the charge building up on a surface, the charge is flowing. And so that is known as electric current. And in physics, the letter for current is a capital I. I don't know why it's I. Some language somewhere, current starts with I, maybe. Okay? And in the olden days, and I might have already said this to you, in the olden days, they thought it was positive charge flowing that made the current. And so when we talk about positive charge flowing current, that's known as conventional current. Now that we know the structure of the atom, we know it's not positive charge flowing, we know it's electron flowing. Okay? And so when we use this current, it's called electron current. Your textbook uses positive charge. Lots of the handouts I give you use negative charge. Negative charge because that's the one that's right. So I tend to use electron current most often by default, but we will use both just so I get you, and we will learn hand rules for both, just so you get used to being able to do both. I think I said the other day, electricians tend to use positive charge. Physicists and engineers tend to use the negative charge. So it's important that you be comfortable with both before you go on. Now, what do we need to have current, to get current to flow? We need three things. We need a material through which it will flow. That material is often called a conductor. And things that make good conductors are things that do not hold their electrons tightly. So metals make good conductors. Things that hold their electrons tightly, those make better insulators. What else do we need for current to flow? We need a difference in potential. A difference in potential. In other words, we need a voltage. We need something that will create a difference in potential between 2 points, and that something is usually a battery, a cell, a power supply of some kind. Okay? That's what supplies our voltage. And then the third thing you need to get current to flow is a closed circuit. If you don't have a closed circuit, nothing will flow, even if you have a battery. So when you turn on a light, what you're doing is closing the circuit. You're closing the switch. Now, that's what you need for current to flow. But if you actually want to build a circuit a circuit that's going to power something in your house, then besides a material, besides a difference in potential, you need something that's going to use the voltage that the electrons are picking up. You need something that's called a load. Okay, so you need a load, or you would have heard of it as a resistance. So a light bulb, a computer, okay, and that's a capital R. So we have a couple of equations from this unit that come up often. One for current, I told you up top, current is capital I, and current is simply how much charge flows by a given point at a given period of time. So I is equal to Q over delta T. Charge is measured in coulombs, time is measured in seconds, and a coulomb per second is what an ampere is. Now, it's written ampere, but we usually tend to say amp, and it's really just a capital A. Okay? So this equation will also come around quite often in this course. And the third equation that comes around often is Ohm's law. And you would have learned Ohm's law back in grade 9. It's V is equal to IR, where V is the voltage or the potential difference, I is the current, and R is the resistance. If we take a look at R then, R is equal to V over I, which means R, resistance, is volts over amps. And a volt over an amp we call an ohm. And the symbol for ohm is the capital omega. Some people see it as a horseshoe. I see it as a stick man who's bow-legged and is bending over to pick up something, so you only see his butt and his legs. But he's a stick man, so his butt isn't very big. Okay? Remember the symbol from grade 9? I hope you remember, maybe. For a resistor, looks like this. The symbol for a power supply is short line, long line. Short line, long line, several sets. The short side is always the negative. The long side is the positive. Okay? The way I tell people to remember it is short side matches the negative. If you took the plus side apart and put it end to end, you would get a longer line. That's the positive. Okay? So this is a circuit then. We use two things to help us in circuits. One is an instrument that we symbolize with a circle with a capital A inside. It's called an ammeter, and it's used to measure the current through a circuit. The other is a capital V, circle with a capital V. It's called a voltmeter, and it's used to measure the voltage in a particular spot in the circuit. Okay? Now this circuit that I drew is just a very simple circuit. In reality, we have way more than one resistor in most of our circuits. We might have 2 or 3 or 4. And if we do, then it means we have a couple ways we can put them together. There's 2 ways that you can put multiple resistance in a circuit. One way to do this is called a series circuit, and the second way is called a parallel circuit. A series circuit, the resistors are in series with each other. The current that flows through one flows through all. There is only one path. It does not have a choice. It leaves the battery, it flows around, it goes through R1, it goes through R2, it goes through R3, it comes back to the battery. In parallel, it's different. In parallel, there's a choice. There's a fork in the road, a junction in the circuit. And so the little electron dudes that are flowing in this circuit have a choice. When they get to this spot, some of them will choose